All right, got my cables, so all squared away. Let's do the last two problems. Problem 4. In a test of effectiveness of garlic for lowering cholesterol, 49 subjects were treated with raw garlic. Cholesterol levels were measured before and after treatment. The changes before minus after in their levels of LDL cholesterol have a mean of zero point 0.4 and a standard deviation of 21. So use a 0.10 significance level to test the claim that with the garlic treatment, the mean change is greater than 0. So first, are our requirements met? Well, sample size is 49. That is definitely bigger than 30. We are all good. So step 1, claim. So claim that the mean change is greater than 0. So mean is greater than 0. Step 2, counterclaim. Mu is less than or equal to 0. Step 3, find your H naught and your HA. H naught is equal to 0 because it's always equal. HA is going to be greater than 0. Number 4. All right, since we're dealing with the mean, we're going to be doing t-test. Our input is stats, because we were given statistics. Mu naught comes from H naught, so that's just going to be 0. X bar and SX, it's our sample mean, sample standard deviation. So we see that's going to be 0.4 and 21. N, we already said, was 49. And then, of course, our mu, that just comes from HA, so greater than mu naught. And we see that our test stat is t equals 0.13. Step 5, p-value. So we should see that, once again, our p-value in our calculator, 0.4472. Step 6, significance level. Significance level, they said, was 0.10. So step 7, what are we going to do? What decision are we going to make? P-value is bigger, so that means we fail to reject H naught. So step 8, our conclusion. So we say that there is not sufficient evidence because we failed to reject to conclude that, let's go back and look, what are we trying to conclude? So HA, right, we couldn't conclude the same thing as the claim. So the claim says that the mean change in cholesterol is greater than 0. We could not conclude that the mean change in LDL cholesterol is greater than 0. All right. So what does this results suggest about the effectiveness of garlic treatment? Well, you might be tempted to say, oh, it can't work, right? But were we trying to show that it worked? That's super important. So the mean change is greater than 0. Is that good? Is it bad? Well, let's figure that out. So it said the changes is before minus after, right? So if it lowered the garlic, right? So again, I don't know what cholesterol levels are. So if you know anything about that, you can feel free to make fun of me. You know more than I do on this topic. So let's just make up a number. Let's say that the before was 100, right? And so if you're wanting to lower the cholesterol with the garlic, then the after should be a smaller number, right? So let's just say 80. So if the change is before minus after, in this case, it would be 20, which is a positive number. So we would want it to be greater than 0. Okay, so we were actually testing that it lowered the LDL cholesterol. right? Because if the change is bigger than 0, that means that you subtracted smaller numbers, right? Your before was bigger than your after. Okay, so that is what we were testing for. So there was not sufficient evidence to conclude that. So then there wasn't enough evidence to conclude that the garlic treatment works. All right, last problem. Number 5. The number of chocolate chips is counted in a sample of 40 Chips Ahoy reduced fat cookies. The sample mean is 19.6 chocolate chips with a sample standard deviation of 4.2 chocolate chips. We want to know if the the Chips Ahoy reduced fat cookies have less fat. We suspect it's because they have a mean number of chocolate chips less than 24, which is in the regular. So maybe the reason why it's reduced fat is because they have less chocolate chips. Well, let's see. So let's test the claim that they have less than 24 chocolate chips. So first, requirements. Can we do this problem? I mean, we're going to do it anyway, right? We've already established that. So n is 40, bigger than 30, totally okay. All right, claim. So mu, because we're talking about mean is less than 24. Counterclaim. Mean is greater than or equal to 24. H naught is equal to 24. HA is less than 24, right? Comes from our claim in this case. Step 4, we're going to use our t-test because we have a mean. If we were using a proportion, of course, we would be using 1 prop z-test. We don't have a proportion, we have a mean, so we're going to use our t-test. Our input, they gave us stats, so we're going to use stats. Mu naught comes from H naught, so that's 24. X bar and SX. All right, we see that that's going to be 19.6 and 4.2. N, we already said, was 40. And then our mu comes from HA, which is less than. Our test stat, it should be negative 6.63. All right, so p-value, number 5. So, is your p-value going to be bigger than 1? No, right? So either you made a mistake, or more likely, there's that E with a negative, right? So when you move the decimal over, if you round to 4 decimals, you should see that it's just 0, right? Part 6, significance level. They didn't give us a significance level, so what do we assume it to be? 0.05. Number 7, p-value is less, so we are going to reject the null hypothesis. So then number 8, there is sufficient evidence because we rejected. To conclude that. All right, so what were we trying to conclude? Let's look at HA. Mu is less than 24, which is the same as our claim, right? So we can just restate the claim. That the mean number of chocolate chips in the reduced fat Chips Ahoy cookies is less than 24 chips. Good. So maybe that is why, right? We suspect the reason why it's reduced fat is because there's less than 24 chocolate chips, which is in the reduced fat. So maybe the reason why it's less fat is because it has less chocolate chips. Good. All right. Like always, if you have any questions, feel free to email me or text me anything.